Hello everyone. This is Mohammad Usman and my group member Crystal has introduced us in the beginning, and she has gone through the pre-processing steps of our project, like what's the goal of our project, and what we are going to do. So after all the selecting time series data, plotting time series, additive model, decomposing time series, trend component, irregular season, non-season. After all this steps, the main steps of this, while predicting any time series data, it's a ARIMA model. So ARIMA is an auto-regressive integrated moving average. So this is used to, analyze any statistical model or any data to anticipate the future trend. So in ARIMA, we have the parameters, which is we have three parameters which need to be considered while applying the ARIMA model on any data set. So three parameters are P, D, and Q. So P is the number of lag perception in the model. D, the number of time that the raw perception or difference, also known as degree of difference, is like when you need to differentiate the data from the past value to the present value or the continuous value. Lastly, Q, the size of moving average window. After that, after we use this line immigration, like immigration is the name of our data set. So we are differentiating immigration with the value of 1. So we have here with the x-axis and the y-axis. So this is the final outcome after applying the differences on a time series data. So after that, the main part to apply the regression to predict the data is selecting the ARIMA model. So there are two ways of selecting ARIMA model. The one is to select manually while considering the three parameters which I discussed before, the PD and Q. And there is another method that is called auto ARIMA. So in auto ARIMA, it will automatically select the best fit model according to the time series of data. So so here in the down, we use auto ARIMA on the library. 224 is the our dataset number in the TSDL library. So when we apply the auto ARIMA function on the data sets, so it returns us the best fit ARIMA model, and I mean the value of PD and Q. So in our case, it's 0, 1, 2. It returns automatically. So what's the value you are going to use in the final outcome? So now it's time to forecast the value. Like we have the ARIMA model, we have the value of the three parameters PD and Q. So we need to forecast. So for forecasting the data, we have the library called forecast, and using this library, you pass the ARIMA model in the forecast function, and it will forecast the value. Like here we are using h is equal to 5, so it's gonna predict the next 5 year the value, and after forecasting, so it's giving us the predicted value for the next 5 years. So the known data is till 1962, and we predicted for the next 5 years, that is 1963 and 1967, between these 2 years. So here you can clearly see the predicted values, and we plot this predicted values using the plot forecast function. After plotting the forecast function in the highlighted area, you can clearly see that these are the forecasted value. So till here, we have a known value, and after 1962, we have a forecasted value. So as from the graph, you can see that the immigration into the United States slightly decreased till 1963 and remains constant till 1967. This, in the end, um, this data set or this prediction on this data set can be used by many industry, many airlines, hotels, or any businesses to develop the business plans accordingly. For example, uh, there's a airlines business, so they can develop their plans, the business plans for the next 5 years by using the regression on the by applying regression on the past data. So it will help the businesses. It is not accurate, but it's close to accurate because predictions cannot be so accurate. So this is the this is what we achieve throughout our project. We use the data set, we use the known value, we apply auto regression on it, we use ARMA model to find the best fit model, and we predicted the next 5 years of values.